Thank you. All right. Thanks, everybody. It's awesome to be here with you today. Yeah, we're going to be talking about DDD. How many of you have heard of domain-driven design before? Okay, awesome. Yep. So this is not that. This is this is durable-driven design. So this is an architecture pattern that we had to implement in our early stage startup when we had a really custom-based Kafka solution. And I kind of want to walk you through a little bit about our journey into durable-driven design. First, a little bit about me. My name is Eli Taylor, head of tech at Equify. I've been in the industry for 12 years. About 7 of that's been in fintech. I've, experienced designing and building scalable applications. Things like DevOps and Agile and lean methodologies, continuous delivery, all that kind of thing across different platforms, ecosystems, all those kinds of things. And cool fun fact is live on a hobby farm with my wife right now in Idaho. It's pretty cool, but we're actually gearing up to go to Arizona, which is where our company is based out of. So what is Equipify? We offer buy now, pay later to financial institutions. So you can kind of think about it like an Affirm or a Klarna, but that's like a consumer-facing application, right? Our motion is more B2B to C. So you'll never see like an Equipify, buy now, pay later app. It'll look like it's coming from your financial institution. So we embed our software inside of the digital banking experience. So it's really cool. There's some challenges with that, though. You have to be compliant to all of the data regulations and security standards that all of these financial institutions are beholden to. So SOC 2, we just got SOC 2 Type 2 compliance. So that was really cool. A lot of work goes into stuff like that. Goal is to be scale up to be in every single checking account across the US. And we got to get there quickly. And Temporal's kind of helping us do that, moving quick. And so it's marketing gals put up some really cool, like what our user experience looks like. This is what it looks like today. It's really smooth, really user-friendly. We've got cool stuff happening with session replay where we can kind of see the users click through and really kind of tune that stuff in. And it's awesome today. But it wasn't always like that. Used to look like this. And that's how I felt every day. So we said, okay, we have this cool idea, this cool product idea, this buy now, pay later thing. And wouldn't it be cool to implement some type of microservices architecture? Well, what you don't realize is when you have microservices in the mix of it is that you've got to put something in between those two services, right? Maybe it's an RPC call. Maybe it's a queue of some sort. For us, it was a Kafka topic. And it seems really cool to begin with, but service A doesn't know what service B is doing. And you end up with something like a service-disoriented architecture. So let's take a look. This is an architecture talk. Let's take a look at kind of what our architecture looked like. So diving into the Rube Goldberg machine, you can kind of see, right, we have some standard stuff. We have an API gateway. Our users interface with our app through that API gateway. There's a service on the back end that handles those interactions. And then there's a ton of other services that have to do and handle all of the complex business transactions throughout that system. And you start out with one service and you glue it together with another service through a Kafka topic. And you're like, okay, that's really easy, right? Oh, well, now I want to read some data. Maybe I'll just throw in a quick RPC call somewhere across to another service layer. And pretty soon, you're in this land where you've got topics all over the place. You try to be really good with your governance and naming conventions, and you're like, what is this queue? The loan processing, the suspended queue thing. Data didn't get over there in the right manner, and so now you have to have someone go in there and tweak the payload and then manually put it back on the topic and hope for the best. So that's kind of what it was. And we have client and vendor services across the web that we also integrate with through other secure communications channels as well, like VPNs, things like that. So that's kind of what the Rube Goldberg machine looked like. And we realized, okay, we got to make a change. So we had to do the great rewrite. How many of you guys in here have done the great rewrite? Yeah? Isn't that fun? We just built this thing. It took us a year, and we're going to rewrite it. Why did we do that, right? So you have to have a really good business case to say, okay, I'm going to throw away all this work that I've done and start from scratch. And the real reason behind it was we were spending so much time on the Rube Goldberg machine that what happens is product comes to you, right? And they say, hey, this is how our buy now, pay later app should work. But the problem is they don't know what the world looks like until they interact with the customers more. And then product requirements might change. And then the problem is that you built your machine, your state management, your orchestration layer, your services that power your product in such a way that doesn't really lend itself to the new requirements that are coming in. And so it requires, you'll notice that a lot of your dev cycles are spent on that orchestration layer and not on the product, the thing that makes your company money, right? So Kafka wasn't really built for that, right? You have to build it. It's like, cool, you got a queue here, and you can make a producer, and you can make a consumer, and you can do all this stuff, but whatever language you choose, you have to build all of the state management orchestration flows yourself. And it becomes pretty fragile. Another thing too is your disk will fill up, and then, okay, cool, I gotta put my infra hat on real quick and blow out all of the full disk, and then I gotta nurse this thing back to health, and I really just wanna work on buy now, pay later. But you can't. So a lot of wasted cycles, patching these gaps, but what you should be working on is this product innovation, the thing that your customers love. You want to deliver value to your customers really quickly. It was really hard, so that's why we had to rewrite the whole thing. So we had some goals, right? So I always say that architecture is leadership, right? And so sometimes when you're doing the rewrite, you have to make that decisive decision, right? The sales always has this thing called, always be closing. I like to say always be architecting. So we have some goals with this. The Rube Goldberg machine, we needed to simplify the workflow orchestration, reduce the technical debt from these custom solutions. We needed to scale these workflows without having to babysit. And it's like, oh no, the marble didn't go down the Hot Wheels track, and now you got to get someone in there to, push the track over and get the marble going. Some other things, obviously, cost savings. I know that temporal is not free, obviously, but there's some other things you can think about, and we'll get to those in a little bit to help you save some money. Fargate Spot being one of those, and then security, super top of mind in our industry, of course. So let's take a look at the turning point, right? So temporal, maybe you guys heard of temporal before, right? So they're a pretty cool company. I was starting to look into them a little bit, and I was like, this seems like a problem that I have, which is workflow orchestration and trying to glue all of these services together. And it seems like they might be able to help me out with this problem that I currently have, right? So their orchestration engine makes that custom logic unnecessary, right? Like we're all, a lot of us are engineers in here, totally competent to be able to make these state management flows, but sometimes you don't want to be working on that because that's not what gives your customer value, right? So this durable state management that temporal allows you to work on the business logic and not on failure, recovery, all those types of things. So what we realized is temporal has kind of largely solved this orchestration problem. Let them be good at what they're good at, and then we can be good at what we're good at, which is buy now, pay later. So once we kind of started evaluating temporal, we did some POCs, things of that nature, and then we actually re-architect the whole system. We rewrote the whole system in TypeScript using temporal to help us out with that. And this is kind of what that ended up looking like, the durable Goldberg machine. So this is a little bit more simplified. Obviously, you still have an API gateway layer. You have your applications need to talk to this API. You have services on the back end. And for us, if a customer wants to accept a loan, right, that needs to go to another service so that loan can transfer funds into the customer's account, right? But that needs to happen. The customer doesn't need to know that our loan processing system downstream of us has failed when it comes back online, Temporal will sit there and wait, and it'll retry, and it'll say, okay, you're back online, cool, transfer funds. But to the user, we can decouple that experience. You're underwritten. We know that you're qualified for this loan that you're about to take out. We've done that with all of our logic. So it says, congratulations, cool, you're good to go. And then later on down the stream, that Temporal will keep track of when this external system to us comes online and then book the loan. Things like email too. So you might have an external service that you use for sending emails, right? And so it's really cool to know that, well, what if that service goes offline for a little bit? And the customer does need to know that they have accepted a loan, and we need to send them confirmation of that. But we can just let them get on their merry way. We don't have to say, hey, wait, hold on, just stay in our app for a second while we do this, and we'll send you this email, right? That can happen totally decoupled from their user experience. So it's really cool. And yeah, you could do that with scheduled jobs. You might have some type of cron system that needs to run on a scheduled basis. You might have some other queues that you need to talk to different services through and call different workflows and all of those things. So durable Goldberg machine, that's what you want. You don't want a Rube Goldberg machine. Okay, so let's talk a little bit about DDD, durable-driven design, right? So I figured that any design paradigm worth its salt might need a couple tenets or maybe a manifesto. I thought manifesto is probably a little bit too much. I'll let the agile folks handle all that stuff. But I have 5 tenets of DDD. You've got the durable model, you've got bounded actions, durable events. The polyglot language, and my favorite, is the Goldilocks zone. So we can dive into these 5. So the durable model, much like in domain-driven design, you have a domain, right? It's all about making sure that you've got the understanding of what your business does in a specific domain and synthesizing that down to the software architecture level so that you're all talking the same language. Durable model takes that a step further and says, okay, engineering and the business, we've done this handshake, but we understand what the domain is that we're operating in, but we're going to make sure all those complex business logic and rules happen and are executed durably, and they happen every time. So no more dropping critical business transactions. Bounded actions. So in context of your domain model, you figure out what are the little component parts that need to happen for a complex business transaction to go throughout the flow of your system. And you map all that out. You've done all the hard work of figuring out what your domain is. You figure out what all of these little units of work are, but they need to happen safely, and they need to happen throughout multiple systems, external to you, internal to you. It could be even your database. So Temporal helps you do that with workflows and activities, so make sure that nothing gets lost in all the chaos of all of that. Durable events, right? In any event-driven system, you need to make sure that when an event fires on service A, service B gets that event and does what it needs to do with it. The problem is with an event-driven system using choreography instead of orchestration is that service A really doesn't care that service B does the right thing with that event. But someone should care, right? Maybe service A doesn't need to care about it, right? Maybe that's not the right abstraction. Maybe the right abstraction is using Temporal's orchestration engine to keep track of the state of that event such that when service A hands it off to service B, that thing happens reliably, durably, on time. So even if the world goes on fire or your server, which your server will, you can respond to that durably, right? So, and that's kind of like where Fargate Spot comes in. We use Fargate Spot a lot for a lot of workflows. If you know anything about Fargate Spot, AWS will rip that container out from under you at any given time, but you get like a 70% discount on that. But we don't care because another worker will come up in its spot, right? And Temporal will just say, cool, I've got another worker now. I'm going to schedule that job that I was already working on, that I know where it's at in its life cycle, and just schedule that back on that new container that comes up. So pretty cool. All right, and super cool. Like when we're doing the grit rewrite, we thought it would be awesome to just use one language. So it's all in TypeScript right now. That's super awesome. All of our build systems are in TypeScript. All of our developers work through TypeScript, which is sweet. It's like, okay, cool. We're all speaking the same language on the front and the back. Super cool, but we're craftsmen here. So sometimes TypeScript's not the right tool for the job. Maybe you want to use Go. Something needs to be really, really scalable. You have a really good use case for another language. Well, what's really hard is if you've built your orchestration layer in TypeScript, well, now you have to rewrite all that same orchestration logic and adhere to all those business paradigms and principles to actually make that communication between those two languages work. And then maybe you're doing something like gRPC, you're creating your own custom protobufs and making sure types get transferred across language boundaries correctly. The nice thing with Temporal's Polyglot SDK is that it handles all that for you in the SDK, and so you can ensure that any message that goes from one language to the other, one workflow starts it in TypeScript, another action gets executed in Go, for example. It's really nice to be able to use multiple languages, use different tools for the job. So, and really this kind of culminates in the Goldilocks zone. So you hired your developers to build you a specific piece of software that meets your business use case, right? In our case, it's buy now, pay later. And it'd really be nice if they got to work on that product, right? And so instead of working on all these custom orchestration pieces, right? And it's really nice that, okay, cool, they're using their dev cycles to build the product that our customers love instead of working on all these custom solutions. So, yeah, it's not too hot, it's not too cold, it's just right. So what are we talking about here? I kind of mentioned earlier that architecture is leadership. So it's hard when you're thinking about going to a new system like Temporal, right? And maybe some of you are kind of working through how you're going to do this today. You just have to make the decision, right? Because you're never going to have the full 100% of the information that you think you need. You're going to probably get to 70%, and you just got to make a decision. We realized that choreography wasn't going to work, right? Trying to, manage workflows from different services through these custom-built Kafka solutions and things like that, and it just was not going to fit the use case. It's not going to get us to where we're at today, where we're serving customers with an awesome buy now, pay later experience. So we needed something to handle and manage that, and that's what Temporal's really done for us. So we're super excited that we get to partner with them, and they get to do what they're good at, which is orchestration, and we get to do what we're good at, which is buy now, pay later, underwriting, and all of the rest. So since we've implemented Temporal into our system, you kind of saw the Rube Goldberg machine that we had before. Well, here's how it's going now. So anyway, so that's been DDD, Durable-Driven Design, and hopefully this design paradigm kind of helps you get to the money pit where you can jump into. So that's my talk. Do we have time for questions? Okay, cool. Yeah, does anybody have any questions? Yeah.
Okay, so I have so many questions. So first of all, it seems like you didn't fully realize the semantic complexity of your business logic up front, and that was kind of an ongoing discovery, and initially you thought choreography would fit the bill.
Yeah.
And then eventually you realized, okay, choreography is not going to work because the semantic complexity is more than we thought it would be.
Right.
Right. Okay. So how did this affect your ability to test your business logic and actually test your workflows in the face of, okay, we've chosen orchestration as our coordination mechanism, but we still have the orthogonal forces of the communication, whether synchronous or asynchronous, and the consistency, whether atomic or eventual, and we need to do compensating transactions and so forth. And how did you test these within the old paradigm versus the new paradigm? How has it affected your ability to provide stability on your platform in that nature? Is this making sense?
Yeah, I think so. So one of the really cool things about Temporal handling the orchestration primitives for you is, like, when you're doing it yourself, you have to come up with all these governance standards, naming conventions, things like that in terms of like, what is this workflow doing? What is the retry mechanism? And maybe that's even a class or a function or something called retry. You need to make sure that same logic happens in another service in a similar way. And you can do that with shared packages. You can do that with different paradigms there, dry, all that kind of stuff. But the nice thing about Temporal doing all of that upfront governance workload for you is that you don't have to think about that. It takes the cognitive load off of you to like design that piece of the system, and then you can worry about all of those other, ancillary concerns that are like more pertinent to that actual business logic.
So has it enabled you to be able to test or achieve better test coverage, more consistent test coverage, better rapid development?
Yeah, so I think so we, truth be told, we should probably have more test coverage than we do. So that's like when you're doing a rewrite, it's like the first thing to go. So it's like we find it easier to test the system because you're not testing against specific orchestration type concerns and testing for those. Like those kind of things are handled. You're more testing the the core business logic and functions that are like handling that transaction within the domain, so to speak. So yeah, so it's easier to test in that regard for sure. And your tests are more focused, right? It's like, hey, this external system downstream of me, I'm testing that I'm getting the right payload back. I'm not really testing is my retry logic and my producer and consumer logic, doing what it should be doing. So it keeps you in the Goldilocks zone, right? Because you're also not testing for the custom system that you built as well. So yeah, that's a good question.
Hey, talk a little bit about the migration from one system to the other. Did you kind of take pieces of the system and change them into workflows, or did you go top down, or did you just completely have a separate thing? Like, how did you go about moving traffic
Unfortunately,
over?
we had a customer on the old system, so we couldn't just like pull the rug out. So we used the Strangler fig pattern. Have you guys heard of that before? Yeah. So we had this old system that was Java, Kafka, all that kind of thing, and we had to be able to like somehow have a feature flag that pointed you to the newer system, depending on whether it was the API gateway layer or some of the back-end components. And so it wasn't like a cool feature flag like using Launch Darkly or StatSig or something like that. It was just like database flag, like, okay, you new customer, you're on this new path. Old customer, you're on, the old legacy stuff. So
there was never a moment when you had one system that was using both Kafka and Temporal?
No. Yeah, it was just like a complete branch of logic, depending on what customer you were. It just went through the new system because we didn't want to like have that exact problem where you're like trying to figure out like how do I now you're creating more service-disoriented architecture because you have two different paradigms competing with each other. So you got this old system trying to use some sort of semblance of Kafka producer-consumer stuff, and then you got an orchestration layer underneath of it with Temporal. It's just it was going to be super hard to handle that.
How did you guys go about monitoring your activities over time, given that you could eventually end up with alert fatigue if activities can fail eventually or recover eventually? How did you prevent alert fatigue, or do you?
Oh, that's easy. We just don't. No, it's an interesting thing because it's like, the whole Roadhouse thing where he's like, hey, it's be nice until it's time to not be nice. And it's like, that's kind of how I think about Temporal. It's like, use Temporal until it's time to not use Temporal. But we use Temporal for pretty much everything. But what I mean by that is like, you could probably hook into Temporal's API and like check for a workflow that's like really messed up, or use the cloud metrics and like alert on that and whatnot. But it's hard because that doesn't give you the full context necessarily. It's like, yeah, okay, a workflow is sitting there retrying to infinity. But I wanted to know some other things about the system. And so what we try to be good at, and we're still working on this to try to get better about it. It's like a data lineage problem almost. So like when your data is going through your system, at each part of the system that it hits, you might want to capture some metadata around that. So like, for instance, if our loan syncing service, if we need to pull like transaction and account data, we might want to know how many accounts that we sank since the last time and have some kind of comparison against that. So it's like if last time we sank like 100,000 accounts or 100,000 transactions and this sync is 50,000, something might be off there. So it's like more of a data lineage kind of concern there. So we're still kind of trying to figure that out ourselves, but I think it's like you want more data around just, is this workflow retrying a billion times? So, yeah.
So in the migration process, were there any concerns about having to do the dreaded rollback of switching back to the old system from temporal as needed, or if it was needed?
That's where I say kind of the leadership component comes in. You kind of just have to make a decisive decision, like we're going this way and we're just going to make it happen kind of thing. But that doesn't mean that you just throw caution to the wind, of course, right? Like you still have to serve customers that are already on the old system. So that's where I'm saying like that feature flagging component really, really will help you with that, because you can say, and you might have some type of metadata around that customer. Like for us, it's like a client ID and some other metadata that allows us to see like that's this individual customer. And so we're in the business to business space, right? So a customer means one financial institution A, financial institution B. We have some metadata around that, so you can segment your traffic to make sure that they go through the new system if they're FIA, client A, and then client B, goes through the old code. So that's a really handy way to like do feature, and you can do feature flagging too on the back end piece, right? Like maybe you, in the great rewrite, you said Oracle DB is bad, and I want to do Postgres or something like that. So your services can even at the back end layer have a feature flag associated with them to send some of that shadow copy of that data to the new OLTP store or whatever you're going to do in that case. So that's how we did that durably.
Okay, time for one more question.
So your development team, how quickly were they on board to the new temporal paradigm? What was the developer experience like to onboard new engineers to the temporal workflow orchestration?
I have one of my developers here today, actually, so definitely come get me afterwards and we can kind of talk to you a little bit more in depth. But it was just kind of that decision, like, hey, we're going to go with temporal. I was fortunate enough where my team had heard about temporal and they're like, oh, this is cool, I want to work on this. So we just kind of just dove into it head first. Yeah, so from the cultural aspect, we didn't have any, problems there. So that was nice.